Hello there. So far, we have learned what and how to derive the special trigonometric limits. Namely, these are first, the limit of sine x over x as x approaches 0 to be 1, and second, the limit of 1 minus cosine x all over x as x approaches 0 is equal to 0. So in this video, our focus this time would be to try out some examples on the first special trigonometric limit. So take note of this one. You may take note of this in your notes or take a screenshot, as we would use this one in our examples. So without further ado, let's have these examples. So we have 3 examples out here. Before we show how to solve this, feel free to pause the video so that you can work on these examples first on your own. Okay, good. So let us start with the first example. We are tasked to find the limit of sine of 3x over x as x approaches 0. Before we start, take note that if we plug in 0 in this function, we'll obtain a value of 0 over 0. And we know that this is an indeterminate in limits, so we can't really conclude anything from this. So given that, let's try to use the first special trigonometric limit. In these types of examples, the key is to observe the constant or the coefficient beside the variable inside this sine function. So observe that we have 3 out here, and using that one, we'll be multiplying 3 over 3 out here. Take note that we can do this since 3 over 3 is just equal to 1. So it's just like an identity element. So if you're quite confused on what is happening out here, so just keep at it on the solution, since you'll see later on why we did this. And so we'll obtain the limit of 3 times sine of 3x over 3x rather as x approaches 0. And now, observe here that if we focus our attention on this one, this is already similar to our special trigonometric limit, but we'll make that more obvious later on. First, take note that we can factor out the constant 3 out here, out of the limit. So moving this out of the limit, we'll obtain 3 times the limit as x approaches 0 of sine of 3x over 3x. And again, let's focus our attention on this limit out here. To make it more like our special trigonometric limit, we'll have a change of variable. That is, we can set y to be 3x. So by setting y equals 3x, take note that x approaching 0, this one, implies that, so if this guy approach 0, it follows that y also approaches 0. This means that we can rewrite this limit as 3 times the limit as y approaches 0 of sine y over y. Now, this is much more clear. We know that this out here approaches or is equal to 1 by our special trigonometric limit. And so we have 3 times 1 out here. Or simply, 3 times 1 is just simply 3. And so we have now found the value of sine of 3x over x as x approaches 0. It is simply just equal to 3. That is how we apply the special trigonometric limit. So I hope you got that one correctly. Let's now move on to the second example. In here, we are given the limit as x approaches 0 of 5x over sine of 2x. Now this time, it is not quite similar to our special trigonometric limit since the sine function is in the denominator. But through certain manipulations, by our knowledge on fractions, we can rewrite this function as this. So take note that these two are just equivalent. But observe here that this here is now much more similar to our special trigonometric limit. So we would focus first on this one. We would try to get the limit as x approaches 0 of this denominator first. So we'll have this. And now, from here, we simply apply what we did in the first example. We focus our attention on the coefficient of the variable inside the sine function. Since we have 2 there, we multiply 2 over 2 out here. Again, we can multiply this since 2 over 2 is equal to 1. And so from here, we'll obtain, so just by commutative rearrangements, we'll obtain the limit as x approaches 0 of 2 over 5 times the sine of 2x over 2x. So just some rearrangements so that if we observe this one, this is similar to what we did out here. So I won't do these steps anymore, but we know that by special trigonometric limits, this here as x approaches 0 is simply approaching or equal to 1. So we have this. And then the limit of a constant is just itself, so we'll have 2 over 5 times 1 out here. Or simply 2 over 5 times 1 is just simply 2 over 5. And so we now have the limit for this denominator out here. So the limit as x approaches 0 of this one is equal to 1 over 2 over 5. Again, this what we obtained is the limit of the denominator. So we have this. And again, just by our knowledge on fraction, we can rewrite this one as 5 over 2. And so we have now found the value of the limit as x approaches 0 of 5x over sine of 2x to be simply just 5 over 2. That is the answer for our second example. I hope you got that one. And let's now move on to our final example. We have here the limit as x approaches 0 of tangent of x over x. Now for this one, it's quite hard to see at first since we don't have any signs out here. So we can't really apply, it seems like we can't apply our special trigonometric limit. But the key thing to remember here is that tangent of x is equal to sine x over cosine of x. So that is a known identity in trigonometry. So we now have a sine. But again, don't forget the denominator x out here, so we'll have this. And so in here, again, multiplication is just commutative, so we can combine these two out here. So we'll have this, the limit of sine x over x as x approaches 0. And let's not forget this one. So we'll have this. And take note that we split the limits out here. So the value doesn't really change even if we don't split the limits out here. But we can do that since this one is an algebraic property of limits. Just to make things clearer. And so, again, if we focus our attention on this guy out here, we know that this is simply the form of our special trigonometric limit. So we know that this is just approaching or is equal to 1. The next problem is this limit out here. We don't really have any known value for this one. But take note that plugging in 0 in this function won't really have any complications. Indeed, observe that 1 over cosine 0, take note that cosine 0 is just equal to 1. Am I right? Yeah, it is equal to 1. And so we'll have this to be equal to 1. And since this one is a real value, we know that this is indeed the limit for this one. And so we have here 1 times 1, or simply equal to 1. And so we have now found the limit of tangent of x over x as x approaches 0 to simply just be equal to 1. And so that is the answer for our final example. So if you want to take a screenshot of this one, you may do so. I'll just clear out the filter out here so I have this there. So you may take a screenshot of this one as your guide in your study on special trigonometric limits. To formally end this discussion, here are 2 exercises that you can work on. So first, we have the limit of sine of x squared minus 1 over x minus 1 as x approaches 1, and the limit of tangent of 2x over 1 minus cosine squared of 3x as x approaches 0 from the left. So these exercises are quite harder than our 3 examples, but the idea is the same. But as a hint for this first example, so let's put here hint for our first example, or first exercise rather. The hint is to apply difference of 2 squares, or if you don't know what difference of 2 squares is, its opposite is the sum and product. No, it's not the sum and product, my bad. It's the sum and difference product of a binomial. So you can use these two in order to answer this one. And then for this next one, oops, it's not moving. Okay, never mind. For this one, as a hint, the key is to take note that we can apply the Pythagorean identity in this denominator. So take note that sine squared theta plus cosine squared theta is equal to 1. If we move this to the right, we'll have sine squared theta equals 1 minus cosine squared theta. And this one is now the same as what we have in the denominator. So you can convert this to its sine squared equivalent value, and that would make things easier in applying the first special trig limit. So I hope you enjoyed and learned a lot from this one. In the next video, we'll be trying out the second special trigonometric limit and some examples applying it. So yeah, you may comment down below if you have any suggestions and recommendations for this video, the playlist, and this channel in general, and as well if you have any questions regarding these 2 exercises, as well as our examples previously or earlier. So yeah, that's it. I hope you enjoyed and learned a lot in this video.